Okay, so let's do some very quick calculations here about molar volume. You already know what a mole is, and we know that in 1 mole of a substance we usually have 6.022 times 10 power 23 particles, molecules, or ions, regardless of you can call them particles, ions, molecules, or whatever you can call it. Okay, we know that concept, but so we know that 1 mole of a substance contains the number of particles. That is the Avogadro's number. We already know that. Next thing that we are looking at now is, okay, 1 mole, what volume? For 1 mole of a substance, what volume does it occupy, especially when we are talking about a gas? Okay, for a gas that contains 1 mole of that very gas, what volume is it occupying at what we call standard temperature and pressure? That's the main concept that we are going to look at in this presentation. So we already know about issues to do with moles. Okay, we say moles are basically, it's like a way of quantifying particles or ions or molecules. Just like the way we look at what we call a dozen, where we have 12. If we talk about a dozen, we talk about 12 pieces. It could be a dozen of books. It could be a dozen of pens or anything. Okay, so we also use the word mole to refer to something like a dozen. Okay, now when we talk about molar volume, we are basically referring to the volume that is occupied by 1 mole of a substance. And in this case, our focus is on gases. Okay, molar volume of a gas. What is it? It means it is the volume. Okay, it is the volume of that gas when the number of moles in it is actually 1. When we have 1 mole of that gas, what volume does it contain? That volume is what we call molar volume. Okay, we can get that molar volume by, of course, dividing molar mass over the density. Okay, just know that volume is got mass over density, but since it is molar volume, that's when we bring in the issue of molar mass times divided by the density. Okay, this formula here. That is basically the basics. Those are the basics. Now, there is something that we call standard temperature and pressure. Okay, when we talk about standard temperature, we are referring to this one here, 273 Kelvin. That is the standard temperature. You can call that 0 degrees centigrade. The units are the ones that are different, but basically 273 Kelvin is what in centigrade is 0 degrees centigrade, and that is the standard temperature. And now the standard pressure is 1 atmosphere. Okay, is 1 atmosphere, and we can abbreviate that as ATM, right? ATM. Now let's look at the major concept here, which is gram molecular volume. This is the volume of 1 mole of any gas at standard temperature and pressure. And that volume usually, for any gas, remember, it could be hydrogen, it could be oxygen, it could be any gas, or regardless of the gas, as long as it is at standard temperature and pressure, and it is 1 mole of that gas, the volume will always be 22.4 decimeter cubed, or basically 22.4 liters. Okay, 22.4 liters. So that means one of the key issues here is for it to be consistent with the units that we are talking about. Okay, you can be writing this decimeter cubed, or you can be writing liters. Okay, be very consistent of that. So here now a law comes in, which is Avogadro's law, basically. That law states that equal volumes of all gases measured at the same temperature and pressure contain the same number of particles. As long as we are having the same volume of gases at the same temperature and pressure, the particles will always be the same. And those particles will always be what we call Avogadro's number. And that number, we have not yet written it here, but that number is 6.022 times 10 power 23 particles. You already know this number, Avogadro's number. Okay. So that is what Avogadro's law says, that for equal volumes of all gases measured at the same temperature and pressure, you will have the same number of particles. So if you have hydrogen at a particular, at the same temperature and pressure, and that hydrogen has the same volume like oxygen at the same temperature and pressure, you will have the same number of particles in oxygen as the number of particles in hydrogen, if the volumes are the same and if the temperature and the pressure are also the same. You have the same number of particles. That's the law there. Okay, so how do you determine the number of moles? How do you determine the number of moles of a gas? You just say it is the volume of the gas at standard temperature and pressure. The units, you can maintain them in liters, and the gram molecular volume divided by the gram molecular volume. Okay, so let's go and check the calculations associated with this concept. I can promise you they are quite simple. It's just that maybe my explanation may not be very rhythmic or steady, but the concepts are very, very clear cut, and we will see this in the calculation here. So what we are seeing here is that they want us to calculate the number of moles in 44.8 liters of hydrogen at standard temperature and pressure. So we are going to use this for our calculations, but let's start. What do we know? So here, from what we have looked at, we know that at STP, that is at standard temperature and pressure, 1 mole of a gas, and in this case 1 mole of hydrogen, right? This case is hydrogen at standard temperature and pressure that 1 mole has a volume of 22.4 liters. That's a statement. It's just rephrasing what we had just talked about just earlier on. That's what it means. Okay? So we want the number of moles, which we don't know. We can say let the number of moles in 44.8 liters of hydrogen be Bx. So saying that 1 mole is basically contained in 22.4 liters. So what about the X moles that we don't know? In this volume, that is 44.8. What will it be? Of course, cross multiply, and X will definitely be 44.8 divided by 22.4, and definitely you can see that we get 2 moles of hydrogen. Will be contained in 44.8 liters. This is our answer there. Yes, it's just applying the principles and you do the calculations, right? So we got the second question, which is what is the volume of 12 moles of hydrogen at standard temperature and pressure? What volume? Just know that 1 mole of oxygen at standard pressure and temperature occupies 22.4 liters. Okay, so 12 moles will contain what? So we can say that let the volume of 12 moles of oxygen Bx. Okay, so we are saying 1 mole is in 22.4, right? What about the 12 moles? So they will be in what? We are not very sure. So this will be 12 times 22.4. So this will be equal to so we are having 12 times 22.4 is 268.8. That is the volume. Okay, that's the volume. And that. So you basically say 12 moles will occupy 268.8 liters. That's the answer. So we move to the next one, which is our last. How many molecules are there in 12 deciliter of oxygen at standard temperature and pressure? Start with what you basically know in terms of principles. We know that 1 mole of a gas, 1 mole of a gas at STP contains 1 mole of a gas at STP is contained in 22.4. We can use the units of liters, okay, here. So that means that what moles, we need to find the moles that are in this. After finding the moles, then we can use Avogadro's number to come up with the number of molecules, right? So what moles are contained in this 12? Okay, so 1 mole is in that. What about these 12 liters? What moles will it contain? That's the question. Okay, so you can just say let X be the number of moles in 12, right? Yes. So what we are saying is 1 mole is contained in 22 point this. What about X that we don't know in 12? What would that be? So this will definitely be 12 divided by 22.4. So this gives us what? Remember, these will be moles. So 12 divided by 22.4, you get 0.536 moles. So remember, 1 mole of any gas, in this case we are talking about oxygen, at STP contains Avogadro's number of particles. Okay, what number is that? It is 6.022 times 10 power 23 particles. So what about 0.536? What will they contain? What particles will be there? Put Y there. So basically it's the same cross multiplication. If I can rewrite it again here, it's basically 1 mole equal to that 22 times 10 power 23. This one like that. So this Y will be equal to 6.022 times 1023 times 0.536. Okay, so what answer do we get there? 0.536 times 6.22. So you get 3.23 times 10 power 23. These are the molecules. Those are the molecules, if I can write it properly here. These are the molecules in the 12 liters. So that is our answer there. Okay, so if we have a gas at standard temperature and pressure, that gas, 1 mole of that gas will always contain 6.022 times 10 power 23 particles. Okay, so that means that if we know the volume, and that volume is at standard temperature and pressure, we can always get the number of particles in that gas. Okay, but we have also noted from Avogadro's law that if we have the same volume of gases, okay, same volume of gases at standard temperature and pressure, at the same temperature and pressure, you will always have the same number of particles or molecules in the two gases, or in those gases that you're looking at. Okay, thank you for listening.